This is component 3 mock A1 and we're up to question 6 now. And we've got an absolutely typical nephron, apart from it appears to be back to front. In most diagrams you'd have the nephron with the collecting duct over here, but this is just going the other way. Yeah. Like a right kidney and a left kidney, mirror images of each other. Name the structures A to F in the diagram opposite and you're getting a point for 2. So A, collecting duct, no problem there. And right, so B and D as well. Right, well we need to remember that it's the wider arteriole going in and then it's the thinner one going out, and I always remember this as being in alphabetical order, so the afferent going to the efferent, so B would be the efferent. So if most people, well, some people got this wrong, and this is the most common mistake. The afferent and the efferent the wrong way around. Arteriole, so a smaller version of an artery. C, glomerulus, and D is the other arteriole, the afferent arteriole. E, that's our Bowman's capsule, or sometimes called the renal capsule, and F, well, it is the descending limb, but that's not good enough. We want, what's the name of this structure? So you can say descending limb of the loop of Henle, or just loop of Henle. So loop of Henle, or the descending limb of the loop of Henle. Draw a line X to show the part of the nephron where most of the water is reabsorbed. So actually, most of the water gets reabsorbed in the proximal convoluted tubule. Water does get reabsorbed in the loop of Henle as well, but actually, if you look in your booklet, it's about 90% of the water gets reabsorbed in the proximal convoluted tubule. So we're looking at X in that area there. So line labelled X. So let's say I'm going to do this properly. There we are. Okay. Draw a line labelled Y to show the part of the nephron where glucose is reabsorbed. Well, same place, proximal convoluted tubule, and so same region there where the blood capillaries are and so on. Explain the significance and the difference in the diameter between B and D. So D, afferent arteriole, is wider in diameter than B, the efferent. And why is that? That's so that we can force the liquid part of the blood through this filter in the glomerulus into the Bowman's capsule. So if you've got a big pipe leading into a small pipe, that's going to increase the pressure. So causes an increase in blood pressure, or blood hydrostatic pressure. What does this do? This forces, a good word like that, or pushes, forces the the plasma, so the liquid part of the blood, into the Bowman's capsule. So the liquid part, and indeed anything that's in that liquid part, everything apart from red blood cells and the larger proteins, plasma proteins. And indeed we could mention the name of this process. It's always good to mention the names. There might be the occasional mark for that. So ultrafiltration will get you a mark as well. Right, things start to get a little bit more complicated here. And the composition of filtrate for a particular substance in the nephron can be given as its renal to plasma ratio. So it's comparing the ratio of what's in this tube compared to what's in the essentially the blood, in the blood plasma. And they're taking various samples in a normal, healthy, untreated person, and they're also treating a kidney with chemical Z and having a look at that as well. And along the bottom we've got Bowman's capsule, then proximal convoluted tubule, and you can imagine the other, loop of Henle and so on in that direction. And this is our ratio. So you can just look at this as more or less really with this ratio. So anything that goes up has got more of it in the nephron compared to the blood. Anything down has got less in the nephron. Explain why urea and glucose have a renal plasma ratio of 1 in the Bowman's capsule. So if the ratio is 1, it's exactly the same. 1 to 1. Gives you a ratio of 1. So why are urea and glucose exactly the same there as they are in the blood? And that's because the liquid part of the blood has just been forced through these gaps, and everything's gone through, the liquid, the water, including the dissolved urea and glucose. It's all gone through and nothing else has happened to it. No reabsorption yet or anything like that. So why is the ratio 1? Because the concentration is the same in the plasma and the filtrate. The concentration of urea and glucose is the same in filtrate or the plasma. Now why? Because the entire liquid part of the blood has been forced through the glomerulus into the capsule. So all the plasma is forced from the glomerulus into the Bowman's capsule. And what are we told? Why haven't they been filtered out? Why don't they remain in the glomerulus? Because they're small and dissolved and can pass through these gaps. So urea and glucose are small and can pass through the gaps, the filtration gaps or pores or whatever words you want to use there. So that's why they are remaining the same. And then in part 2, the ratio for urea increases. So the ratio for urea is increasing. That is saying there's more in the filtrate, in the nephron, than there is in the blood. So in this region here, the relative amount of urea goes up. And you need to sort of go, right, well the urea can't just go up because we're not putting any more urea in, so something else must go down. And that's really the answer. So let's again explain the ratio. So the ratio goes up. Use figures from the graph, okay, so the concentration of urea increases in the tubule. The concentration of urea increases in the tubule. It goes from 1.0 to 1.7, the ratio. And we've used some figures now. So use figures. Okay, I've used figures. 1.0 to 1.7 on there. Yep, use the figures. I've done the job it wanted. And now we just need to explain, well, why is the urea going up if we're not actually putting any more urea in? Well, that's because the water is being reabsorbed from here. So we're getting water coming out of here, and that's going back into the the plasma in the blood. It's going back into the blood. So water is reabsorbed into the blood capillaries. And just to remind us again, the urea, so the urea is not reabsorbed. So for reabsorption in the proximal convoluted tubule, you remember, we're absorbing a lot of glucose, water, but not urea. Use the figures from the graph opposite to describe and explain, again we're using figures, the ratio for glucose in both the untreated healthy kidney and the kidney treated with chemical Z. So we're comparing this line here and that line there, and this is the untreated healthy one, and then this is one with chemical Z. And so let's do the normal one. That's the one that you know. So in the normal untreated healthy kidney, the glucose ratio is going from 1 down to 0. So let's say which one we're talking about. So untreated healthy kidney ratio, and we're not talking about urea, it's glucose it's wanting here. Some people talked about urea. Ratio goes from 1 down to 0. 1.0 down to 0.0. And that is because glucose is reabsorbed. So glucose is also reabsorbed. So out of here into the blood capillaries. So glucose is reabsorbed in the proximal convoluted tubule. Probably can't read that, but you can hear it. And then, so we're on 3 marks here, so we've probably got 2 of them already. We just need to sort of go, what's going on with chemical Z? Oh dear. It appears to be doing the same sort of thing as urea previously. So if the ratio is going up, it's probably not being reabsorbed, and it's going up because the water is being reabsorbed. So this is prevented by chemical Z. So reabsorption of glucose is prevented by chemical Z because, and the numbers to back it up, use figures, the ratio goes from 1.0 to here, probably about there, so to 1.4. and that's backing up what we're saying there. And why is it going up? So goes up due to the same thing as before, the water being reabsorbed. And lastly, suggest how chemical Z could have caused the effect described above. Well, we've got no idea what chemical Z does, and the guess that we're going to have is not going to be an absolute wild guess. They say suggest, but really they want you to use your knowledge of how this process works and from your notes to sort of suggest something that's not happening. It's a common trick with exams. And so we sort of go, well, how is glucose normally reabsorbed? And perhaps chemical Z mucks that up somehow. So you know that the reabsorption of glucose is an active process, and so that's going to be using sort of proteins and ATP and co-transport proteins and things like that. So we're going to make a reasonable suggestion that chemical Z has some sort of an effect on that. So chemical Z could inhibit active transport, e.g. blocks protein carriers possibly. And we can suggest inhibits active transport, ATP supply, something like that. But this process is active transport, so chemical Z could stop that from happening. And that's 80 marks. So lots of marks available here. 3, 4, 3. Big chunks when it's just using your existing knowledge of what's going on in the nephron and applying it to this slightly new situation. And there's a bumper amount of marks for doing that.